is high. So in this video, we will see the assertion, reason, question of electric field and charges. So these are the 4 options. So let us see the first assertion part of question number 1. It is said a point charge is brought in an electric field. The field at a nearby point will increase or decrease depending on the nature of the charge. Second, the reason is the electric field is independent of the charge. We already know about the electric field that it depends on the nature of the charge and the position of the point with respect to the charge. So let us understand it more well. Suppose this is a electric field. Okay, this electric field is E1. Now, if we are bringing a point charge and here we have brought a positive point charge, okay, in this particular electric field E1. So if you see here, we know for point charge, electric field is radially outward. And by sign convention, we know that this is positive side and this is what? Negative. And we know electric field is what? The summation. Okay, we always take the sum, right? So if you see here in this region, if I take the electric field, in this region, you see both the electric field are in the same direction. So it will be E1 plus E2. E2 is the electric field due to the positive charge. And in this region, the opposite region, what you will see, this is E1 is in this direction, E2 is in the opposite direction, right? So it is E1 minus E2. That means due to positive charge in this region, the field is decreasing, and in this region, the field is increasing. Similarly, if we bring minus Q charge, we know the field is what? Radially inward, right? So in this case, from this side, what you can see is this will be a minus, okay? So E1 minus E2. That means in this region, the electric field is decreasing, and in this region, the electric field is increasing, depending on the positive and the negative charge. So we can write the assertion is what? The assertion is true, but the reason is false. Why? Because electric field is not independent of the nature of the charge, but it depends on the nature of the charge. So the correct option is option C. Assertion is true, but the reason is false. Okay, let us see the second question of electric field and charges. These questions are assertion and reason. So first, let us see the assertion part of question number 2. So it is mass of a body decreases slightly when it is negatively charged. Reason is charging is due to actual transfer of electrons. So we have already studied in charges that there is a relationship between charge and mass, that whenever electrons are transferred, mass of the body is what? Increasing, okay? The body which gains electrons, it has increase in mass. That means you can take an example here. This is a body A, this is a body B. So here initially they were electron and proton number to be 5, and in this body also electron and proton number were 5. So now this body A is donating 2 number of electrons to the body B. So you can see here the number of electrons have become 7 and the number of protons is 5. And here the electrons number has become 3. Proton is 5. So this body has become positively charged, body A, and this body has become negatively charged. So in this case, the body which has become negatively charged, you can see the number of electrons have increased. Electrons number is increasing. That means the mass of the electrons is also increasing because electrons have mass, right? So whenever a body is negatively charged, you can say that there is slightly increase in the mass, not in decrease. So the assertion is wrong. Next is charging is due to actual transfer of electrons. Yes, it is true. Whenever body is charged, there must be actual transfer of electrons. That means body will become positively charged when there is transfer of electrons, means when it is donating electrons, okay? And body will become negatively charged when it is accepting electrons. In either of the cases, there must be actual transfer of electrons. Clear? So what you can write, the correct option is option D. Assertion is false and the reason is true. The assertion part is what? In this question, let us see. So here it is said mass of a body decreases slightly when it is negatively charged. And the reason is a charged body can induce charge in an uncharged body. So we have already studied that whenever there is a transfer of electrons, okay, there's transfers of mass as well. Suppose we can take the example, this is a body A, this is a body B. So initially it was having electron E to be 3 and proton to be 3. In both the bodies, the number of electrons and protons are equal. So when there was a transfer of electrons, okay, from the body A to body B. So we are taking here 1 electron is transferred from body 1 to body 2. So here the number of electrons are increasing, that is it has become 4, and here the number of electrons are decreasing, it has become 2. That means body A became positively charged, body B became negatively charged. So in this case, we know that when there is transfer of electrons, the mass is also getting transferred. That means there is slight increase in the mass of the body when it is negatively charged. It is not decrease. So you can say the assertion is wrong. And the reason is what? A reason given is a charged body can induce a charge in uncharged body. So this is true that if you are having this body is uncharged and if you bring a positive charge close to this negative charge, then we can induce negative charge, means opposite charge can be induced. Similarly, if you are bringing positive negative charge, so in this uncharged body, positive charge can be induced. We have already studied in charge by induction that positive charge induces negative charge in uncharged body, and vice versa. So we can say the assertion is false and the reason is true. But this reason is not true for this particular assertion. Clear? Let's see the fourth question of assertion in region, chapter 1. So the assertion is, if a conducting medium is placed between two charges, then electric force between them becomes zero. And the reason is given: dielectric constant or permittivity of a conducting medium is infinity. So this we can understand by Coulomb's law. So first let us say this is a charge Q1, this is a charge Q2, and they are separated by a distance r. So by Coulomb's law, what you can write: force for vacuum, free space, okay, or air, you can write one F is equals to the force, electrostatic force of attraction or repulsion. It is 1 by 4 pi epsilon naught Q1 Q2 by R square. Since here we have introduced a conducting material, okay, medium. This is a conducting medium introduced. So for that case, you can write the permittivity epsilon. Okay, we know permittivity epsilon is for any medium, right? And this Q1 Q2 by R square is same. We can write the permittivity of relative permittivity, or you can say dielectric constant, the ratio to be equals to what? Epsilon by epsilon naught. So this is permittivity of medium, this is for free space, and you can write this permittivity of the medium as K epsilon naught. So when you will substitute it here, K epsilon naught, what you will see that the force is 1 by K times of the original force, that is 1 by 4 pi epsilon naught Q1 Q2 by R square. And here this K, it is the dielectric constant, or you can say the electric permittivity. And for conducting material, we know K is infinity. So 1 by infinity will give you what? 0. That means force is what? 0. So when a conducting medium is introduced, okay, between two charges, then the electric force is becoming 0. And this has become 0 because of the dielectric constant, right? Which is infinity for the conducting material. So what you can say, the correct option is option A. Both assertion and reason are true. And the reason is correct explanation of the assertions. So the correct option is option A. So we'll come up with the next question, question number 5. Till then, bye.